to also look at how to calculate parallel connection with resistors. In the parallel connection, we said the components are connected with the same joint or junction, or they are connected with a common point. All the components are always connected with a common junction. Then to find the current in parallel connection, we said the current in parallel connection are always the sum of the current in the various components in the circuit. Then the voltages that is flowing through the circuit is always the same. Then talking about the total resistance, we said the total resistance is always less than the smallest branch resistance. It's always less than the smallest branch resistance. Now let's look at how this parallel connection is done. Now this is a parallel connection involving another 3 resistors. So we name one R1, R2, then R3. R1, R2, and R3 are connected in parallel. Now the current that will flow through this circuit, that is the total current here, they are separated in a common junction here. And as they are separating, we will name this side I1, then this side I2, then that side I3. So it means that the currents in parallel connections are always different, but voltages in parallel connections are the same. So if you want to find the sum of the current in parallel connection, it's just to add the current in each component in the circuit, just like this. Now to also find the total resistance, we said the total resistance is less than the smallest branch resistance. It's less than the smallest branch resistance means that we say the total resistance is equal to, you have 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3, depending on the number of resistors in the circuit. So to find the total resistance in parallel, this is the formula to do that. Now total current in parallel. Total current, we say total current is equal to I1 plus I2 plus I3, also dependent on the number of resistors in the circuit. So since the voltage flowing in the circuit are the same, to find the total voltage, we said this is equal to, according to the Ohm's law, the total current multiplied by total voltage. So voltages are the same in parallel connection. So to find the voltage, multiply current by the resistance. So these are the expressions to find in parallel connection of resistors. Now let's look at a question that will help us to understand more. Now this is a question for us. He said find the total resistance in the circuit. So to find the total resistance in the circuit, he said RT is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. So you now substitute your values, get 1 divided by 2 plus 1 divided by 3 plus 1 divided by 4. So this one is very simple. This is we just find the common factor here. And the common factor in these numbers, we can say it is 12. So 12, we say 2 can enter here, 6 times 1, you say 6. Plus 3 can enter here, you see 4. 4 times 1, you see 4. Plus 4 can enter 12, 3 times 1, 3. So this is equal to 13 divided by 12. 13 divided by 12 will give us 1.08 ohms, because we are looking at what total resistance, 1.08 ohms. Now our next question is to find the total current in the circuit. The total current in the circuit is to find the current that flows through the whole circuit. So we say I is equal to the voltage divided by R. So the voltage that is given is 12, then the total current, so the total resistance is 1.08. So you get 11.1 amps. 11.1 amps. So this becomes our total current in the circuit. Now, the next question is to find the current in each resistor. Find the current in each component. So, current in R1. The current in R1, the I1 is equal to V divided by R1. The V is 12 divided by R1 is what? 2. So 12 divided by 2 is just 6 amps. So our current in resistor 1 is 6 amps. Now current in R2. Current in R2 gives us I2, which is equal to V on R2. So our V is given us as 12. So 12 divided by R2 gives us, that is 3, so 3, and this will be equal to 12 divided by 3 will give us 4. So our current in resistor 2 is 4 amps. 4 amps. Now current in resistor 3. Current in resistor 3 is also called I3. So the I3 is equal to the voltage divided by R3. The voltage is 12 by 4. So 12 divided by 4 will give us 3 amps. So 3 amps becomes our current in resistor 3. So this is a question that we are asked to solve involving resistors connected in parallel. So thank you. If you enjoyed this class, just like, subscribe, follow for more and more videos. Thank you.